I've had many students asking about the difference between an isostere and a bioisostere, so I thought I would give you guys this to see if this might help. Now, my example in class about a bioisostere was the bisphosphonates, and these are bioisosteres of hydroxyapatite. So if I were to draw a molecule of hydroxyapatite, I start with a central oxygen that is bound to a phosphate group on one side and a phosphate group on the other side. This is hydroxyapatite. That's good. I don't know how to write. Hold on a second. Let's do this again. Okay, so now hydroxyapatite is the structure of the bone. It's the matrix of the bone, so it has phosphates in it, so consequently your bones need phosphates. But the bisphosphonates is a class of drugs okay, because I'm writing big. This is really interesting. So the bisphosphonates have the same structure as the hydroxyapatite. It's got the phosphates in between, but instead of the oxygen, you have a carbon, okay, and it's a CH2. Okay, so that's bound. So that's your bisphosphonate. Now, between these two molecules, these are isosteres because you have the oxygen being substituted for the methyl group. That makes them isosteres. They're bioisosteres because both bind bone. Okay? Hydroxyapatite is laid down in, essentially it's like tiles of hydroxyapatite binding to the bone. And with the bisphosphonates, then this molecule binds to the bone as well. The bone recognizes it as something that will bind because of the phosphate groups, but it cannot undergo the destruction like hydroxyapatite can when osteoporosis sets in. All right? So I hope that helps. So the isostere is the fact that you have a substitution between the two. The bioisostere is that both have the same biological activity. Now, in terms of, is it classical or non-classical? These are classical because when you go back to Grimm's hydride displacement law and you look at his table, that the oxygen can be substituted by a methyl group and still have the same number of valence electrons and still have the same van der Waals radii. So I hope this helps.